Hey everybody, we're going to do an example using some of our rules of probability. So I think you should already be seeing what I am, which is this question is going to have to do with a 52 card deck of cards. If you're not familiar, we've got they're kind of divided up into, let's call them teams or suits. These symbols define the suits. So the top one here is spades, then we have hearts, diamonds, clubs. And then they've all also got, there's other groupings of symbols. So if we look top to bottom, we see on the left edge all the aces, then all the twos, threes, and up to tens. And then we have what we call the face cards, jacks, queens, and kings. And then we also can divide them up by colors. There's two black symbols and two red symbols. So there are these nice objects besides having lots of games that we can play with them. Statistics teachers love them because we can ask lots of different interesting questions about grouping them together in probabilities and such. So I'm going to, we're going to take a look at this experiment, drawing three cards, meaning, let me explain it a little more detail. I shuffle the cards so they're in a random order, right? They're not in the order we see here. We don't know what we're going to pull out. We're going to pull one card out and we're not going to replace it, pull another card out, not replace it, pull a third card out. So when we say without replacement, it means once we've chosen one, it doesn't go back in, okay? And the question is, what's the probability of drawing three clubs out, okay? So let's go ahead and start that question. Let me get my pen going. And I'm going to start. I'm going to start with an easier question. Okay. So let's start with the question of drawing two clubs. So I'm going to name some events. Draw a club the first time. C2 will be draw club the second time. Okay, and so now the question of drawing two clubs means I have to do C1 and C2, right? So I'm asking what's the probability of C1 and C2, and I'm going to use my multiplication rule. So this is the probability of C1 times the probability of C2 given C1. Okay. All right. Let's start with the probability of C1. Probability of C1 is what's the probability of drawing a club the first time, okay? So let's look at our cards. When we're looking at this, this is like a sample space for the experiment of drawing one card. So on this first pull, we're looking at the sample space for that first pull. Our whole experiment's going to have more than one pull, but for one pull, this is the sample space. And all the cards, because we've shuffled them up randomly, are equally likely, okay? And so the question, what's the probability of pulling a club? We can just count how many clubs are there out of the total number of cards, okay? Well, there are 13 of each kind, spades, hearts, diamonds, and clubs. So there's 13 clubs. And there are 52 total cards, okay? So that's probability of pulling clubs. Now, let's ask, what's the probability of pulling clubs again, given that we already picked one, okay? So let's just imagine for a second I know which one I picked. Let's say I picked the 4 of clubs, so now it's gone, okay? It doesn't matter which one, whatever one we picked would be gone. I just picked one so we could visualize it. When we go to pick again, now these events are not independent because picking a club the second time depends on what happened the first time. Because we picked a club, there are now not 13 clubs left, there's only 12. And there's not a total of 52 cards, there's a total of 51, okay? And so that multiplication problem right there will give us the result. So let me compute that number really quick. We get 52 times 51, below 13 times 12. So let me just, oops, sorry, I'm hitting wrong buttons here, times 12 divided by 51. I'll just round to a couple of decimal places. Let's go to 3 decimal places. And this works out to be 0.5, 0.059. I'll round it right there, okay? So the probability of picking a club first and second is 0.059 approximately, right? We're doing a little bit of rounding here. Okay, so that wasn't the question that was asked though. Let's add a third. So I'm just gonna add an event now. C3 is equal to draw clubs third time. And now our probability question looks like this. What's the probability of pulling clubs the first time, and the second time, and the third time? Okay. Now, here's the little trick I'm going to use here. This event, pulling clubs the first 2 times, I can think of that as a single event, right? It's made of smaller events, but this and connects them, and when we connect events with ands, we get new events. So that's an event, right? Pulling 2 clubs in a row is an event. And I can just use my multiplication rule, right? Let me write my multiplication rule up here. Oops. Let's do an eraser. I don't want to say this out loud. It feels like I'm getting better at oh, see, now I said it out loud and I didn't do it right. Okay, so the probability of A and B is equal to the probability of A times the probability of B given A. This rule doesn't care how complicated these events are. So A could be something like, what's the probability of drawing a king while standing on your head and flipping a heads and rolling a 7, right? It could be a long, complicated event, right? That's all encapsulated in A. So in here, I'm thinking of this whole thing, C1 and C2, as like my event A. It's this thing, and this is my event B. So this becomes the probability of C1 and C2. That's the probability of A. It doesn't look like a C. Times the probability of C3 given C1 and C2. Okay. So let's go ahead and solve this. We already figured out the probability of C1 and C2. Right? That's what we worked out up here. I'm going to keep it as a fraction for now. This is 13 over 52 times 12 over 51. I'm just writing this number the way it's written up here, right, instead of my decimal. And we're going to multiply this times what's the probability of pulling clubs the third time, given that we already picked one the first and second time. So now I've pulled the 4 of clubs, maybe I pulled the 8 of clubs as well. Okay, so right, again, there's nothing special about 4 and 8 here. I'm just picking 2, but all I want you to see is that there's 2 missing. So if there's 2 clubs missing, we're not putting them back. What's the probability of pulling a third? Well, now instead of there being 13 clubs or 12 clubs, we're down to 11 clubs. And there's not 51 or 52 cards left. We're down to just 50 cards left, right? So 13 times 12 times 11 over 52 times 51 times 50. And this looks like, give me 1 second. Let's just add it to this. This is 11 divided by 50. We get approximately 0.013. Okay, and that's it. That's how we did this. Okay, that is the answer to the question of drawing 3 clubs. Now, let's take a look at this one other way, though, to see a little pattern that emerges. Let me go back. Let's go back a couple steps. So when we first computed this, I'm going to just rewrite this line up here that I put a star next to here. We wrote the probability of C1 and C2 times the probability of C3 given C1 and C2. But instead of computing this, let's look at this, P of C1 and C2. Let's look up here. Now I'll make a nice circle next to where I'm looking. P of C1 and C2 can be written this way. Okay, so notice what I did. Let's get another color up here. I took this, right? And because of what I have up here, I replaced it with the right-hand side of this equation at the top to get this down here. And this we had already worked out up above. But notice the pattern that's here. I just multiplied the probability of getting clubs the first time, right? That's 13 out of 52, times the probability of getting clubs the second time if I got clubs the first time. And then I multiplied it by the probability of getting clubs the third time if I got clubs the first and second time. Okay, and notice that's exactly the little what we had worked out right up here. Okay, so with that in mind, let's just, without writing out events and thinking too hard about this, let's notice the pattern we got. What if I ask the question, what's the probability of pulling 5 clubs in a row? All right. Well, following this pattern, we'll look at the probability of pulling one the first time times the probability of pulling one the second time. Remember, this only works this way because we're not replacing them, meaning each time we lose a club and we lose a card in the deck. So then we multiply by the probability of pulling a club the third time, the fourth time, and the fifth time. Right? So each time we lose a club in the numerator, we lose a card in the denominator. I'll let you multiply that out if you're really curious about what the number is, but it's a nice pattern that shows up that we can use for problems of this type. Okay, that's it for this one. Thanks, everybody. I will see you next time.